Okay, we're going to do a little stoichiometry, and this is going to be a gram to gram problem. First thing you need to do is balance your equation. So on this side I've got 1 sodium, and over here I've got 1 sodium. Here you've got 2 hydrogens, and on this side you've got 3 hydrogens. Over here you've got 1 oxygen, and you've got 1 oxygen. So the main thing we need to do is balance the hydrogens. So the easiest thing to do, here I've got let's make this an even number. So let's put a 2 right here. I now have 2 sodiums, 2 oxygens, 2 hydrogens, and another 2 hydrogens, which is 4 hydrogens. So I need to get 4 hydrogens over here. So by placing a 2 here, 2 times this 2 gives me a total of 4 hydrogens. So my hydrogens now are okay. 2 times 2, I get 2 times 1, I get 2 oxygens. 2 times 1, I get 2 oxygens. I now have 2 sodiums, so I need to put a 2 right there. Now my equation is balanced. Okay, so the problem says what mass is sodium hydroxide? So I'm looking for mass of sodium hydroxide. So over here, I'm going to write what I'm looking for. So question mark, grams of NaOH, okay? Will be produced if you start with 10.5 grams of water. So this is what I'm starting with. So I've got 10.5 grams of H2O. I need to go from grams to moles. Always your first step. Anything you want to do, you have to go from whatever it is to moles. So in order to get from grams to moles, I need my molar mass, and this is my molar mass of water, which is given to you right here. All right, so to find my molar mass of water, I need to look at my periodic table. Here's hydrogen, which is 1.008, and we look at oxygen, which is 15.999. Okay, so I got 2 hydrogens, so I'm going to say 1.008 times 2 plus 15.999 for my oxygen. All right, so that's going to give me 18.015 grams of water. And this is for every 1 mole of water. Okay. So as long as you have grams up here, you have to have grams on the bottom. So this will always be 1 mole. This will not change. So 1 mole over the mass. Also, make sure that when you're looking at this on for your EOC, for your STAR test, you have to use whatever number is given to you on your periodic table. Different periodic tables will have different numbers, but you have to use the whole number. We don't round anything until the end. Okay, so keep all the numbers there. Don't be lazy. All right, the next step is I have my molar mass. Now I need to go to my ratio, because if I stopped right here, I'd be at moles of water. I need to get to grams of sodium hydroxide. So now I can compare moles with the mole ratio, and that comes from your balanced equation. So this is from the balanced equation. Okay, so I'm looking up here, and whatever is up top needs to be on bottom. So I'm looking for moles of water. Over here it says I've got 2 moles of water, right, for every 2 moles of sodium hydroxide. Okay. All right, so if I stopped right here, I'd be at moles of sodium hydroxide, but I need to get to grams. So my next step is molar mass, and this is the molar mass of sodium hydroxide. So I know that for every 1 mole of sodium hydroxide, I got to go back to my periodic table. Here's sodium at 22.990, hydrogen 1.008, and oxygen 15.999. All right, so those are the values I'm going to be using. So I have 1.008 plus, I forgot what I'm doing. Oh, 22.99, which is your sodium, plus 15.999 for your oxygen. This is going to give me a total of 39.997 grams of sodium hydroxide. All right, so if you look at this, look, grams of water cancel. Moles of water cancel. Sodium, moles of sodium hydroxide. So I'm left with units of grams of sodium hydroxide, and that is exactly what we're looking for. Next step, I need to multiply everything on top and divide by everything on the bottom. Do this my way and you'll get it right. If you don't do it my way, you probably won't get it right. All right, 10.5 times 1 times 2 times 39.997. No, you don't have to put the times 1 if you don't want to. All right, next thing I need to do, divided by, open parentheses, 18.015 times 2 times 1, you don't have to put the 1. And we get 23.312. Now, my answer here has 3 significant figures, so my answer can only have 3 significant figures. So even though it's 3, 1, 2, blah, 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 all I'm worried about is the first 3 numbers, and there's our answer. Now, had you been given another problem, so we'll look at this, we'll look at another problem here. It says, what mass of sodium, that's enough, is required to produce 3.7 grams of H2. So we're looking for the mass of sodium, and they're giving us 3.7 grams of H2. So we're looking for grams of Na. And we're starting with 3.7 grams of H2. Guess what my first step is? That's right, it's molar mass. It's just super exciting. And this is the molar mass of H2. So if we look at our periodic table, remember hydrogen 1.008, so 1.008 times 2, and I get 2.016 grams of H2 for every 1 mole of H2. All right, next step. I'm now at moles. See, grams, cancel. Now I'm at moles. I need the ratio. Where's the ratio come from? That's right, it comes from the balanced equation. All right, so if we look at our balanced equation up here, I need moles of H2 on bottom, and I know that there are, this is a 1, right? There's nothing there, so it's 1. So I know that for every 1 mole of H2, I get how much sodium? I get 2 moles of sodium. Okay, remember these coefficients are the number of moles. All right, so the next step. After I do that, I need my molar mass. And this is my molar mass of sodium. That's what we're getting to, because right now moles of H2 cancel. So now I'm at moles of sodium. All right, so I need to get to grams. I know that for every 1 mole of sodium, there are, look at our periodic table, 22.990. All right, so I have 22.990 grams of sodium. Oops, that's an equal sign. All right, so moles cancel, so I'm left with units of grams of sodium, which is what we were looking for. Now all I have to do is multiply across the top, divide by the bottom. So in this case, let's move this up some. Okay, so you can see. All right, let's do parentheses. Parentheses, 3.7 times 1, I'm not putting times 1, 2 times 22.990, close parentheses, divided by, open parentheses, 2.016 times 1, close parentheses, I get 84.39 grams. All right, problem. If I report this number, I will get my answer wrong, even though it's correct, because the problem up here, I can only have how many sig figs? I can only have 2 significant figures. So my answer can only have 2. I need to round this to 84 grams of sodium. And that would be your problem. So if you can go gram to gram conversions, you are doing a wonderful, wonderful job.